Okay, for number one, we did A. We just finished A. Now we're on B. It says the polynomial P of X, which reminds me of just part one there. It says where the degree n, so it's not a fourth degree polynomial, it's an nth degree polynomial, where n is greater than or equal to 1, so like 1, 2, 3, 4, 5, yada, yada, yada. They go on to say that P1 equals P2 equals P3, up to Pn, up to the degree of the polynomial, is equal to the number 1. So it's related to the first question, by the way. It says, show that Pn plus 1 does not equal 1. All right? Then it says, given that Pn plus 1 equals 2, find Pn plus r, where r is a positive integer. Find a positive integer r independent of n such that Pn plus r equals n plus r. Boy, that's a lot of stuff written down, by the way. So let's go over here, and we'll go back to the whiteboard. And I'm going to write down, this is part B now. And let's write this down. So I'm going to write a polynomial. And again, I want to read that again to you. There's a degree to the polynomial. It's n greater than or equal to 1. All right? So I'm just going to write a general statement down. All right? And what they say, the polynomial P of X has degree n greater than 1, it satisfies where I get this evaluation to be 1, by the way. So let's write this down. So I'm going to write down P1 equals P2. They actually told me this, by the way, is equal to P3, is equal to P4, yada, 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 up to the degree of the polynomial Pn, and now would equal 1. And this sort of reminds me of this thing over here. So I could write that down now. So I'm going to write the polynomial down. Actually, you know what? I'll do it right over here. I'm going to say it's k. There's some multiple. And then it's going to be, x minus 1, x minus 2, x minus 3, and I got to go yada, yada, yada. And where would I stop? X minus n. Now, for this to evaluate to 1 at those numbers, 1, 2, 3, 4, up to n, they would all, like this thing would just evaluate to 0. So I have to say it evaluates to 1. I'm going to put plus 1 down here. I'm going to say k can be any real number. By the way, I probably should have said that up here too, by the way. K can be any real number except 0. All right, I'm going to say k is not equal to 0. So k can be any real number, k not equal to 0. All right, so I think I got that part done. And what I'm saying over here is, no matter what I evaluate this thing at, whether it's 1, whether it's 2, whether it's 3, up to Pn, this thing is going to evaluate to the number 1. And why is that? This thing would always produce a 0 for the numbers 1 to n. And I just get 1 there. So that's okay. We got that done. All right, now I want to keep reading it. They go on to say that show Pn plus 1 is not equal to 1. Let's write this down. So I'm going to put down P of X again. That's k, x minus 1, x minus 2, x minus 3, dot, 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 up to x minus n plus 1. What did they say? Show that P n plus 1 does not equal 1. All right? So to do that, I just got to plug it in. Let's do that now. So what do you get? You get P of X. And what do you get over here? You get k still. And n minus 1 would give you n. Let's keep going. And then you're going to get n minus 1, n minus 2. I'm just plugging it in, by the way. Dot, dot, dot. Let's talk about, the last two factors over here. And, looking at these things, it doesn't look that bad. If I'm evaluating n plus 1, it would be, the last factor would be n plus 1 minus n was just 1. What goes over here? This would be 2. All right, so forth and so on. This would be 3, so forth and so on. So 1, 2, 3, up to n. That doesn't look too bad, by the way. And it's going to be plus 1. Let's keep simplifying this over here. And this is going to be k, right? And I notice this thing as a notation to it. And what would the notation to that be? It would be, let's see, that would just be n factorial, right? Big N factorial, plus 1, all right? Now, what did they say, all right? Show that it's not equal to 1. Well, again, remember, n is some integer. It's a positive integer. So n could be 1, could be 2, could be 3, and k is not 0. All right, k is not 0, by the way. It's not any real number, by the way. So this thing would never be equal to 1. And why is that? This could be some number. All right, that's going to be some number plus 1. It's not equal to 1. All right? So it should be clear for n is a positive integer greater than 0. That means 1, 2, 3, 4, so on. Certainly positive integers. K not equal to 0. That k n factorial is not equal to 0. And that's why I'm saying this thing is not equal to 1. So we just showed that. Then we'll go on to part C. Oh, I'm sorry, there was another question over there. Let me make sure that is true, though. Yeah, okay, so there is another question. Sorry, I didn't quite see that. I'm reading now. So given that Pn plus 1 is equal to 2, right? Let's just think about that for a second. So if P of n plus 1 is equal to 2, for some given n, by the way, I'd have to think about what I'm given over here. So let's write this down. So P n plus 1. Well, you know what? I kind of just did that, the n plus 1. And what does it turn out to be? It turns out to be k n factorial plus 1. But they now tell me this is equal to 2, right? Which is an important fact at this point, is I could probably figure out what they want. And let's take a look at that. So if that's true, I think I could figure out the k. So k n factorial is going to be equal to 1. So k would have to be equal to 1 over n factorial. All right? So I'm going to say if this is true, our polynomial, let's take a look at that. P of x would equal, the k now I know to be 1 over n factorial, and then you're going to get x minus 1, x minus 2, x minus 3, and then it goes yada, 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 up to x minus big N, and again is some integer, like 1, 2, 3, 4, and then plus 1. All right? So what I want to do now is we're going to write down P n plus little r. All right? Let me just read that again. So it says find P n plus r, where r is a positive integer. So again, they tell me r is a positive integer. So what do? I write it down. 1 over n factorial. And then you're going to get, n plus r minus 1. I guess I got to write that down, don't I? And then you're going to get n plus r minus 2. And you keep marching along, right? And you go towards the end. And I'm going to write down, I guess, the last two factors. And if I do the n plus r minus n, I would get r. And I want to point out, these are going to be going up by 1. All right? So what goes over here, this would be r plus 1 now. All right? Then r plus 2, blah, 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 until you get to that n plus r minus 1. All right? So I'm looking at this thing over here, and I'm wondering what to do now. I'm going to read it again. It says, find a positive r independent of n such that p n plus r, they want this thing to be equal to n plus r now. All right? That's what they want it to be equal to. So I'm kind of looking at that, and I'm going to, make a stab at it. I'm going to say r is equal to 2. All right? And let's see what happens if r is equal to 2. Let's write this down now. So if r is equal to 2, I'm going to get p big N plus 2. Remember, r is a positive integer, by the way. This is going to be 1 over n factorial. And I think I can write this down now. And let's put it, I'm kind of looking when I got up there, and it's going to be n plus 2 minus 1, which is n plus 1. What's next one going to be? And it's going to be n plus 2 minus 2, so it's going to be n. All right, that's not so bad. What's next one going to be? Well, it's got a nice pattern to it. N minus 1, then n minus 2, yada, 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 yada. Let me write the last two factors down. There's still a plus 1 over here. What are the last two factors going to be? Well, it's n plus 2. So if I look at that, it's n plus 2 minus n. I'm looking at this last factor, by the way. The n's disappear, you get 2. All right? And then what would be here? This would be 3, and then you get 4, and then you get the so forth and so on business over here. So let me just think about this over here. What do you get over here? Well, on top, you're actually getting n plus 1 times n factorial over n factorial plus 1. All right? Let's take a look at this, and what do you get? Well, the n factorials cancel off. It's not 0. And you get n plus 1 plus 1, which is n plus 2. All right? So the r is equal to 2. And we're done with that one. Thank you.